Hello people! In this video we are going to take a closer look at audio visualization and beat detection. The visualization part is really simple, yet quite beautiful if you ask me. We don't even need fancy math here, as we can use a Unity internal function to analyze the music for us. We start by creating a class called visualization. At the top we define an enum for different modes. Due to time we will only cover the ring you saw earlier, but I will show you some other ideas later. We cache some variables we need for the ring, like its radius and how many segments it should contain of, as well as some arrays that are necessary for the audio analyzation. In Awake we are going to set some values and initialize our ring. We are basically just preparing the arrays to fit our amount of segments and then instantiating that amount in game objects that have a line renderer attached to it. This handy internal function that I mentioned earlier is the audiosource.getSpectrum you see in my update. After using this function to update our spectrum, we then need to update our extents accordingly, so that each line on our ring will have a length that is relevant to the spectrum of the song. You might have noticed that I'm only using a percentage of the spectrum. This is due to the fact that the later iterations aren't quite as springy, which would result in a rather dull-looking visualization. We are using a while loop to iterate over every segment and get an updated length for it, which is clamped by two if statements between a minimum and a maximum. And yes, I am aware that I could have just used mathf.clamp. All that is left now is to utilize these new values in the update ring function by calculating the radius and setting the positions on each line renderer. Well, and then of course stare at our beautiful creation trying a bunch of different settings. And maybe even your favorite song.
Alright, okay, alright, okay, alright, okay, I'm feeling you, yo. All my people in Brooklyn and you know we're hot, I said, we don't stop the body rock. All my people.
Whoa, sorry, got a little distracted with body rocking there. Well, I hope you aren't too tired yet, as it's time to make it fancy. We are now using some math I crammed together doing some research on beat detection. A lot of these formulas are quite confusing to me as well, but I'm going to link some of the resources down below. So in our beat detection class, we are going to begin with setting up variables as usual. Some of them are for skipping beats. Imagine me air quoting here. This is due to the fact that this isn't a 100% accurate way to do it. Not only because this would be really hard, but also because it would need to preload the song and analyze it before starting to play, and all of this would drag this video out too much. But don't worry, you'll end up with a cool version you can tweak and play with if you keep following. In Update we are getting the spectrum data again, but this time we are using it to calculate where a beat should be by looping over each band and evaluating its average power, which we'll then use to loop through all of them and get the dB increments to add them up as an onset. We then look for the largest delay value and the tempo, as these go hand in hand. Now it's time to calculate notations. We are basically looping through all of them looking for the highest value, as this is a potential beat. We now know if there is a beat playing right now, so we can check our conditions to see if we are allowed to trigger our on-beat event. And that is it. What you'll end up with is a nice beat detection that is tweakable through the editor values. It can be very on point with simpler tracks like this one. However, with very complex songs with many lows and highs close to each other, there are some misses. Anyways, I hope you enjoyed this. The full project source code is available for patrons, including the behaviors I haven't explained here, like this line for example.